Hello everyone. Today I'm going to be discussing sentiment and emotion analysis in natural language processing. These are techniques that allow computers to determine how people feel based on the text. And we see this technology used every single day, whether it's product reviews, social media, politics, or even cybersecurity. In this presentation, I will explain what sentiment and emotion analysis are, how they work, the major methods used, the challenges involved, and where we see this field is going to be in the future. So let's discuss why sentiment and emotion analysis matters. Every day, millions of people post their opinions online through reviews, tweets, Reddit discussions, and comments, but because there is so much data, it is impossible for people to read and analyze all of it manually. This is where sentiment and emotion analysis becomes very useful. These methods allow organizations to automatically understand how people feel and determine where they need to go from there. For example, companies use sentiment analysis to monitor customer reviews. Governments and political groups use it to track public opinion. Researchers use it to understand social trends. And ultimately, I chose this topic because it is one of the most practical and widely used applications of natural language processing. Also, for my own personal studies, I am doing a research project that pertains to sentiment analysis. What is sentiment analysis? Sentiment analysis is the process of identifying whether a piece of text is positive, negative, or neutral. In other words, it measures the overall emotional tone, and that is sometimes called polarity. For example, in this table on the right, if someone says, "This movie was amazing," the sentiment is positive. If someone says, "The service was terrible," the sentiment is negative. And if someone simply says, "The package arrived yesterday," that would be considered neutral because it does not express an opinion of positive or negative. So sentiment analysis is mainly concerned with whether the text is favorable or unfavorable, or neutral. What is emotion analysis? Emotion analysis is similar to sentiment analysis, but it goes a little bit further. Instead of simply deciding whether a text is positive or negative, it tries to identify a specific emotion. For example, a sentence may express joy, anger, fear, sadness, surprise, or disgust, and the list goes on and on. If someone says, "I am thrilled with the results," the emotion is joy. If someone says, "I am worried about what will happen," the emotion is fear. If someone says, "This is incredibly frustrating," the emotion is anger. And this tends to be a little bit more difficult because two sentences may contradict each other. One sentence may have anger while another expresses sadness. So that would be double the sentiment. How sentiment and emotion analysis works. Most sentiment and emotion analysis systems follow a very similar process or pipeline. The first step is collecting the text data. This could come from reviews, tweets, Reddit posts, or survey responses. Then the next step, the text is cleaned and pre-processed, and this is a very pivotal step for this pipeline. And this often includes converting text to lowercase, removing punctuation, removing common words or stop words, and breaking the text into tokens, which is often called tokenization. After pre-processing, features are extracted from the text, then a model is applied, and this model predicts the sentiment or emotion. Finally, the results are evaluated to see how accurate the model is, and normally during this step, the results from the model are compared to the human form of sentiment analysis, where This is normally called manual coding, and a human will go in and read the text and give their opinion on the sentiment. This pipeline is very important because with poor pre-processing, this can reduce the quality of the final prediction and mess up the entire case study. Lexicon-based methods. One of the simplest approaches to sentiment analysis is the lexicon-based method. And in this approach, the system uses a dictionary of words that already have sentiment values assigned to them. For example, words such as excellent, happy, great are considered very positive words, while words like terrible, bad, and angry are considered negative. Some common lexicon-based tools are Vader, TextBlob, and Afin, and these methods are relatively easy to use because they don't require any training data. However, they often struggle with context. And a prime example of this, the phrase, "the movie was sick," may be classified incorrectly because the word sick can either be negative or slang for something positive, so it's a double sentiment, and it's not quite sure how to classify that. Machine learning methods. To improve performance, especially after lexicon-based methods, researchers began using machine learning methods. So instead of relying on a dictionary of words with sentiment, these models learned the patterns from labeled examples. Some common machine learning algorithms are naive Bayes, logistic regression, and SVM, support vector machines. Before the text can be used, it must be converted into features, and this has a collection of common techniques such as bag of words, TF-IDF, and n-grams. And these methods are usually more accurate than lexicon-based approaches because they actually learn the data rather than go through an entire set dictionary of the data. However, they do require a large amount of labeled training data and need more preparation and do take a little bit more time. Deep learning and transformers. So after lexicon-based and machine learning-based methods, researchers in the most recent years have decided that deep learning is another approach that they can take for sentiment and emotion analysis. Models such as LSTM, BERT, and Roberta can understand context much better than earlier methods. For example, take the sentence, "I thought the movie would be awful, but it was actually great." A simple dictionary approach may focus on the word awful and incorrectly predict a negative sentiment. However, a transformer model like BERT can understand that the overall meaning of the sentence is positive, even though there's a dictionary-based positive and negative in the sentence. Transformer models currently provide the highest accuracy, but they require much more computing power and are often way harder to explain. And this is just an example demonstration of the three models that I've talked about in the past 3 slides. One of my favorite examples is how all 3 of these models took the second sentence, "Great, my laptop crashed again." So in this case, lexicon took this as positive because the word "great," even though it's not a positive sentence. The machine learning didn't really know what to do with it, so it's in the neutral, it's in the middle. And then the transformer at the end decided that this was a negative sentence, which is true. So a comparison of the models in terms of accuracy, complexity, and the training needed. So this slide compares the three main approaches. Lexicon-based methods are the simplest and fastest, but they usually have the lowest accuracy. Machine learning methods are more accurate, but they require training data. While deep learning methods are generally the most accurate, they're also the most complex and computationally expensive. So, looking at this, there really isn't a single best method for every situation, and it's on a case-to-case basis, depending on the amount of data available, the level of accuracy needed, and the computing resources available. Datasets and evaluation metrics. To evaluate a sentiment or emotion analysis model, researchers must use benchmark datasets. Some of the most common datasets include IMDb movie reviews, which is very common in the coding world, Twitter sentiment datasets, the Stanford Sentiment Tree Bank, and the Go Emotions datasets, which are all publicly available online. Researchers then measure how well the model performs using metrics such as accuracy, precision, recall, and F1 score. These are usually the four that are always used. Accuracy measures the percentage of predictions that are correct. Precision measures how many of the predicted positive results are actually positive. Recall measures how many of the real positive examples are found. And F1 score is useful because it balances precision and recall. So let's talk about some of the challenges and limitations. Although sentiment and emotion analysis are both very powerful, they still face many challenges. And one of the major challenges is sarcasm. For example, the sentence, "Great, another Monday morning," appears to be positive because of the word great from a dictionary standpoint, but most people understand that this is actually negative. But the machines do not. Other challenges include slang, cultural differences, ambiguous words, and multilingual text. The same word can mean many different things depending on the context, and the models also struggle with all of these things. There are also concerns about bias in training data. So if the training data is biased, then the model's predictions may also be biased. Privacy is also another issue, especially when analyzing social media posts, which is mainly what sentiment and emotion analysis is used on. Real-world applications. Sentiment and emotion analysis are used in many real-world situations. One of them being business, where businesses use them to analyze customer reviews and monitor brand reputation. Another one is healthcare, where healthcare organizations may use them to identify patient emotions or mental health concerns. Another one is politics, where political organizations use them to track the public opinion of a candidate. Education, where in education these methods can be used to analyze student feedback. And in cybersecurity, where researchers can analyze social media and online discussions in order to understand public reaction to threats or attacks. And this just shows that sentiment analysis is not just a research topic. It actually has many practical, real-world applications that are prominent in everyday life. My personal real-world application, as I mentioned earlier, I am doing a research project through FAU where I use sentiment analysis to study online discussions on Reddit, which are related to Taiwan semiconductors. My goal was to determine whether public opinion was mostly positive, negative, or neutral, just because there are a lot of U.S. tariffs coming in and taxing the production and the buying of semiconductors, and also there's a lot of global conflicts about semiconductors. So basically, I collected text data from the Reddit post, and we also scraped the comments, and I used multiple different models for pre-processing. I used BERT Topic, Text Blob, and Vader, and we saw how all three of these methods worked for this case study. So I found that it worked fantastic for straightforward examples. I provided a couple, like, great semiconductors are awesome. That's obviously positive, but the one challenge that I encountered time and time again, and I noticed this when I was doing the manual coding, was that sarcasm and mixed emotions sometimes made the analysis a lot more difficult. Also emojis, because emojis can be taken in a lot of different senses, and humans like to utilize the different type of ways you can take them. So overall, this project helped me to see both the usefulness and the limitations of sentiment analysis in a real-world setting. Future trends. In the future, sentiment and emotion analysis will likely become much more advanced, where researchers are already working on multimodal systems that combine text with speech, facial expressions, and voice tone. And future models will also improve multilingual support and provide better real-time analysis. At the same time, there is growing interest in making these systems more ethical and explainable. As I've talked about, privacy tends to be an issue in this. And as AI continues to improve and gains more traction, sentiment and emotion analysis will become even more important in understanding human communication. To conclude, sentiment analysis identifies whether text is positive, negative, or neutral, while emotion analysis identifies specific emotions such as joy, anger, or fear. Today we looked at several different approaches, including lexicon-based methods, machine learning, and deep learning. We also discussed the major challenges such as sarcasm and bias, as well as the many different real-world applications and the future of this entire sentiment analysis. Overall, sentiment and emotion analysis are very important areas of natural language processing because they help computers better understand human language and emotion. Thank you for your time.